Question 5. Write root 50 plus root 8 in the form of k root 2, where k is an element of the quotient set. So k, the number that's stuck in front of the root 2, can be a positive whole number, a negative whole number, or a fraction, or a decimal, or a ratio, or a percentage. But ultimately it will be a whole number, positive or negative, or a fraction, because we wouldn't be using decimals in these questions. So we're going to rewrite root 50 and root 8. We're going to try and rewrite each of them as something root 2, and then we can add the numbers that are in front of the root 2, and our answer will be something root 2, and that's something that k must be an element of the quotient set. So we start by just writing out root 50, root 8. Then root 50, I'm going to rewrite as root 25, root 2, because 25 times 2 is 50. Remember, I want to have a root 2 at the back. And root 8, I'm going to rewrite as root 4, root 2, because 4 by 2 gives us 8. And again, I want root 2 at the back. I can simplify the square root of 25 to give me 5, but root 2 cannot be simplified because 2 is a prime number. And the square root of 4 I can simplify to be 2, and again, root 2 I cannot simplify. So root 25 root 2 gives me 5 root 2. Notice I've no square root anymore, because the square root of 25 is 5, because 5 squared is 25. And the square root of 4 is 2, in the same way, so I don't have a square root anymore. So root 25 root 2 gives me 5 root 2. The root 2's just stay the same. And root 4 root 2 gives me 2 root 2. Again, the root 2's just stayed the same. So now we can add them because they both have root 2 at the back. So in the same way that you would say 5x plus 2x gives you 7x, 5 root 2 plus 2 root 2 will give us 7 root 2. So our answer is 7 root 2, which is in the form of k root 2, where k is an element of the quotient set. So that k ended up being 7. So we have it in the form of k root 2, which is what we wanted.